Good morning. I'm going to present you the relationship between somatic cell count and milk yield in the standard dairy sheep breed. In recent years, there has been increasing emphasis on reducing milk somatic cell count to improve milk quality in ruminants. In particular, in dairy sheep, somatic cell count in bulk milk has been used as an indicator of hygiene, animal welfare, and prevalence of mastitis. Somatic cell count is often included in the parameters for determining milk price in several European countries, and individual recording of somatic cell count has been implemented for several European breeds in France, Spain, and Italy. And it has been included as a selection criteria only in the Lacan's selection scheme. In Sardinia, there is an increasing interest in the somatic cell count because a specific part of the rural development plans is aimed at improving animal welfare, and bulk milk somatic cell count is the main indicator for evaluating if the farmer may access to the economic subsidies. Moreover, farmers involved in the selection scheme are debating the inclusion of somatic cell count as selection criteria. It is well known that somatic cell count is considered an indirect measure of subclinical mastitis, but although the relationship between subclinical mastitis and milk yield are well known, the relationship between somatic cell count and production traits are controversial. To assess this relationship, it is crucial to show farmers the potential effect on production traits and to assess the profitable economic weight of the somatic cell count in milk pricing. Moreover, in dairy sheep, the relationship between somatic cell count and milk yield is often deduced indirectly from the fact that infected ewes show higher somatic cell count and at the same time a lower milk yield. So the aim of the study is to evaluate the raw relationship between somatic cell count and milk yield, and to estimate the genetic correlation between somatic cell count and milk yield in view of including somatic cell count as a selection criterion for mastitis resistance. From 2000 to 2011, test day records were collected from two flocks of our agency. In the first flock, test day records were monthly recorded. In this flock, voluntary culling based on milk yield and other morphology was performed. In the second flock, test day records were fortnightly recorded, and each cohort was simultaneously slaughtered at the end of the full lactation without voluntary culling. Here are the main features of the two flocks. In the second flock, you can see a higher number of lactation use and test day records. Here are listed the recorded traits at test day level and lactation level: milk yield, fat and protein yield, fat content, protein content, somatic cell count, and somatic cell score. Then we empirically considered the lactation performed by ewes with a higher probability to have an infected udder when at least two somatic cell count were above 600,000 cells per milliliter, or one somatic cell count was above 1,500,000 cells per milliliter. So, test day data were split in two health status classes. In the first class were included test day record referred to lactation performed by ewes with a higher probability to have a healthy udder. In the second class were included test day referred to lactation performed by ewes with a higher probability to have an infected udder. Descriptive statistics and correlations of somatic cells with production traits were calculated by flock and health status class. In order to quantify the effect of the dilution, the dilution effect of the decreasing trend of milk yield with the lactation stage on somatic cell score, we calculated a new variable that we named expected somatic cell count on the basis of the amount of somatic cells at the first test day. This amount was assumed to be the individual base level of somatic cells. So, then we considered the somatic cell score, the expected somatic cell score, and the trend of the expected somatic cell score with lactation stage is only affected by milk yield, and it measures the dilution effect. And the correlation between the expected somatic cell score and milk yield is expected to measure the relationship caused by the decreasing of milk yield. Then we calculate the difference between the daily somatic cell score and the expected somatic cell score, and the single test day milk deviation from the first test day milk yield, and the correlation between the deviation in somatic cell score and deviation in milk yield was calculated by Flock and health status class to estimate the relationship between deviation from the base level of somatic cell score and milk yield. For heritability and genetic correlation between the milk yield and somatic cell score at lactation level, we use the heritability were calculated separately by Flock and with the following bit rate repeatability animal model. In this model, we have three fixed effects, a combination of here age and lambing season, age parity and lambing month, and a fixed effect of milking length class. Then there were the random genetic effect, the random permanent environmental effect, and the random residual effect. Here, the first results in this table are shown the descriptive statistics by Flock and health status class of test day and lactation records. The first result is that the somatic cell count at the test day lactation level were approximately twice in the first flock than in the second flock. For this reason, we named the first flock FH, H is for high level of somatic cells, and the second flock was named FL because L is for low level of somatic cells. Production traits were similar but slightly higher in the flock with a low level of somatic cells. And the percentage of lactation included, performed by users considered healthy, were about 47% in the flock with high level of somatic cells, and about 60% in the flock with a low level of somatic cells. The different percentage of infected animals does not seem sufficient to explain the difference in somatic cell count, suggesting that other management factors are involved. The correlation at lactation level of the somatic cell score was negative but weak with milk yield, fat yield, and protein yield, close to zero for fat content, and moderate and positive for protein content. The correlation between milk yield and somatic cell score by Flock were negative but very weak, and it changed in signs when we consider the health status class. So these results indicated that a moderate negative relationship between lactation milk yield and lactation somatic cell score is detected only in use with a higher probability of having an infected udder. The correlation at test day level of somatic cell score with milk yield, fat yield, and protein yield were negative and moderate, and it was positive and moderate for fat content and protein content. The correlation between milk yield and somatic cell score at test day by Flock was stronger than in the lactation one. This suggests that there is a potential impact of the dilution effect. Some authors have studying the relationship between milk yield and somatic cell count, introduced the dilution effect in goat and cow milk. And the dilution effect is when low milk yield corresponds to a higher percentage either for fat and protein or somatic cells. And this is a crucial point for the farmer, which may be induced to incorrectly conclude that there is a negative effect of somatic cell count on milk yield and vice versa a positive one on content. So the correlation between milk yield and the expected somatic cell score by Flock were stronger than the actual relationship between milk yield and somatic cells. And the explanation is that at the end of the lactation, the amount of somatic cells is lower than in the initial one, as this difference is more evident in healthy use. As we see, the correlation between the deviation in milk yield and the deviation in somatic cells by Flock, the correlation is very weak, it's close to zero, and these results show that the negative correlation found between somatic cell score and milk yield is likely to be affected by dilution effect. We found only a negative correlation, but very weak, in the class of infected ewes in the flock with a high level of somatic cells. And these results indicate that the detrimental effect of somatic cell score on milk yield is negligible, and it exists only in ewes with a high probability to be infected. Moreover, this result is not repeatable between flock. And on the contrary, in healthy animals, the relationship is moderately positive. Here are the same phenomena. the two pictures. In the first picture, you can see the relationship between the daily somatic cell score and the milk yield. In the second, the relationship between the deviation in somatic cell score and deviation in milk yield. You can see there is a weak relationship, but there is evident the inversion of the slope of the regression between two graphs. Irritability were estimated between flock. Irritability of milk yield was 0.37 and 0.47. Irritability for lactation somatic cell score were 0.12 and 0.22. Both irritabilities are in agreement with the estimates in other breeds. Higher irritability estimated in the flock with low levels of somatic cells are probably due to the better accuracy of measures and consistency of data. The genetic correlation were low, 0.18 and minus 0.06 in the two flocks, discordant between flocks, and with high standard errors. And these findings support the hypothesis that the true genetic correlation between lactation somatic cell score and lactation milk yield are around 0. The different sign in the two flocks may be interpreted in the same way of difference found in literature between breeds. In the flock with high level of somatic cell, the genetic correlation was unfavorable and in agreement with values found in dairy cow and Lacan breed. In the flock with low level of somatic cell, the genetic correlation was favorable and in agreement with value estimated in Spanish breed. So the different behavior of the two flocks suggests that genetic parameter estimate for somatic cell score at the population level should be checked by flock or at least flock class, accounting for different average somatic cell score levels. So in conclusion, the raw relationship between somatic cell count and milk yield, even if negligible, are negative only in animals with higher probability to have an infected udder. In any case, the dilution effect should be considered when test day yields are analyzed. The level of irritability of lactation somatic cell score and milk yield are in the range of literature, and genetic correlation between somatic cell score and milk yield are low and different in sign in the two analyzed flock. And the overall results, combined with the asymptomatic nature of subclinical mastitis, makes it particularly difficult to convince Sardinian farmers to select against somatic cell count, mainly in absence of an adequate payment system. In this situation, the implementation of selection for other morphology that was shown to be favorably related to machine make-ability and other health may be an efficient and already available way for genetically improving other health. Thank you.